So we took a look at the channel partitioning MAC protocols where we either share the channel with either time slots or different frequencies. So basically they share the channel very efficiently and fairly at a high load, but they're very inefficient at a low load. You can't use all the bandwidth even if you only have one active node. The random access MAC protocols, on the other hand, are efficient at the low end because a single node can fully utilize a channel, but they're inefficient at the high end because then you can have collision overhead. So basically you're either sitting idly, basically waiting for the link, or you're losing some time because of collisions, or having to wait some time for your binary back off. So taking turns protocols were invented to provide the best of both worlds, basically provide efficiency at low usage and high usage. But as you're going to see, they have some disadvantages as well. So basically, one thing you can do is to poll. So you have to have a master on the network that's going to invite the other hosts to transmit. This is typically used with dumb devices. It's not used that much these days. There are issues here. Obviously, there's the polling overhead, so you're going to waste some bandwidth trying to poll. There's the latency of waiting to hear back. And then if the master fails, you have a single point of failure, and then basically you may end up in the situation where nobody is using the network, even though they all have something to send. A better way to take turns is the concept of token passing. In this sense, you have a control token that's passed from one node to the next sequentially. So you lose the whole need to have the master server. So basically, whoever has a token can send a message. They can send it for as long as they need it, and then they release a token when they're done, and then the next user takes it. There's no collisions, and everybody gets to use the bandwidth fully when it's their turn, so the bandwidth is used efficiently. The issue is token overhead, which isn't really too bad, but there's some token overhead. There's some latency waiting for the token to get passed, which isn't as bad as in polling. However, you can't really get past the single point of failure of the token, the host of the token for some reason failing and not being able to pass along the token to the next user. So token passing, like the token ring network and FTDI, those things never really took off either. And one of the problems is these tend to be physically more expensive to develop. So the cards tend to be a little bit more pricey, and that's kind of the hidden part of networking. Is a lot of things aren't picked because it was the best technology, but usually the best technology at a particular price point. Next, we'll talk a little bit about how the cable access network works. So in a cable system, which is used for a lot of at-home network users, are basically on the cable access network. A lot of cable providers like Comcast and Cox Communications provide this feature. We're going to talk a little bit about how this works. So basically, you have a cable head end which is called the cable modem termination system, and that basically provides a connection to the ISP and also gets you to the greater internet and also to all of the local users in an area. So in every area there's basically a cable head end that provides services to X amount of homes. And at each home you have your cable signal coming in. It's going to have TV signal and your computer signal, so you have to have some sort of splitter to split the signal. You may also have a the splitter, and you may also, if you have a voice over IP phone, you may actually have to have a special cable modem that can handle that and go to your in-house phone system as well. Might branch off here. So basically the way that works is the incoming, this is basically a broadcast medium here. So incoming frames and TV channels and controls are transmitted downstream at different frequencies. And upstream, all of the users are sending stuff back to the head end at different frequencies and in different time slots. And of course the reason for the slight difference is in this situation you have every user, especially for the TV channels, you're just going to broadcast it. So every user is going to share the TV data, and then every user is going to, filter the internet data to sort out what it wants. On the other end, each user, the cable head end now has to differentiate, as opposed to the user differentiate who belongs to what. So the cable head end keeps track of that by having the different homes transmit their data in different time slots. So basically going downstream, usually have, and this is probably changing, but it's probably higher these days, but at least a few years ago when the text was written, you would have a 40 megabit per second downstream broadcast channel, and you have a single head end that's going to transmit into the channel. Going the opposite way, you have 3 megabits per second upstream channels, and basically you're going to do some time slots for each of the specific channels assigned to each specific user. So the protocol that's used to make this happen is called DOCSIS. That's basically Data Over Cable Service Interface Specification. And basically you're doing frequency division, multiplexing over the upstream downstream frequency channels, and you're additionally doing time distribution on the upstream with slots being assigned. So basically, the way this is set up, there are basically many slots, and if everyone is trying to get a slot at the same time, sometimes the slots are not available, so you may have some contention for a particular slot. So basically, you use a a binary backoff to have access to the different time slots. So this basic cable access network basically combines all of the different link layer protocol mechanisms for sharing media all into one specification. So let's summarize what we've talked about. So we talked about we can channel partition by time, frequency, or code. Actually, we didn't cover code, so we just talked about time division and frequency division. We talked about, the other option being random access, and we focused on CSMA CD. We determined that carrier sensing is easy and wired technologies, but not so much in wireless. We covered CSMA CD. Here, we're going to cover CSMA CA in detail when we talk about wireless networks. And we talked about taking turns where we either pull from a central site or we pass a token. This is used in Bluetooth, which we're going to talk about in later lectures, and it was used in FDDI and Token Ring, and those have since gone away basically due to their cost and their complexity. So this is basically, we are going to conclude here for now with this lecture. In the next lecture we will talk about, pick up talking about local area networks.